Everyone. Welcome to the presentation of our paper titled Did They Direct the Violence or Admonish It? A Cautionary Tale on Contronomy, Androcentrism, and Bad Translation Foibles. This work will be presented at Africa-NLP Workshop, co-held with EACL 2021. Our work sits at the intersection of the study of contronyms, the study of gender in languages, neural machine translation, and the technique of translation. The talk is roughly organized into three sections. The first pertains to introduction and background. The second pertains to experiments and results. And the third pertains to the recommendations that we would like to make to Google Translate specifically on the basis of the observations and results that we obtained through our empirical experiment. Let's dive in. First section, introduction and background. Let's begin with a brief study of neural machine translation. Well, I guess one can say that the story kind of begins with the myth of the Tower of Babel, which is a narrative found in the book of Genesis and Old Testament and Hebrew Bible. With regards to this, I'd like to quote German mystic Jakob Boehmer's quote, "Adam knew the property of all creatures and gave names to all creatures from their essence, form, and property. He understood the language of nature, the manifested and formed word in everyone's essence. For thence, the name of every creature is arrival." And this notion of universal, artificial universal language, or the interlingua, has kind of spanned through different centuries. In the 17th century, you had the famous exchange of thoughts between Marie Mersenne and René Descartes. A brief of the history of machine translation is present in the slide, and to kind of take this with a little bit of a grain of salt, because this is not strict sense categorization, but this is a kind of a recurring theme and a recurring timeline that you will get to see in many of the NLP papers that we passed. So the first era spanned from 1950 to 1980. That's called as the era of the rule-based machine translation. And then came EBMT, example-based machine translation, that spanned from 80s all the way to 1990. Then came the era of statistical machine translation, and we are currently living in the world of neural machine translation. Contronyms. Well, let's begin with these two sentences. On the left-hand side, you'll see the image of a bag of seeds, and the sentence that is associated with this picture is that, "I see that you did seed the lawn." Now let's look at another picture, which talks about how to see. The word seed appears in absolutely opposite context in these two sentences. In the left one, you will clearly see that the seed, whereas the second one talks about removing seed from the tomatoes. So what are these contronyms? Contronym or contronym is a word which has two or more generally accepted meanings in the English language that directly or generally contradict each other. So in this case, it can have a positive connotation in the left-hand side of the image, which basically talks about adding seeds, and the negative connotation being removing seeds, that is seen in that article, which is titled "How to Seed Tomatoes." This institution of contronomy has been studied since the 1960s. Joseph Tweedle Shipley is widely credited to be the inventor of the term autoantonyms or contronyms. And they're also called as Janus words. And so on the right-hand side, we can see, we'll also see examples such as adumbrate, anabasis, annual, apology, all being used in an absolutely opposite sense, depending on the context. So there are some very nice papers that we encountered that kind of provide, kind of deep dives into the world of enantiosemy. The first paper that we would like to highlight basically talks about the limits of polysemy, and within the context of legalese or legal English, Vladimir Ozyumenko's work is certainly noteworthy. We kind of were able to glean a lot of nuances and build a lot of really important ideas for our paper through this work. And in the context of neural machine translations, we would like to point towards the work of Hadil Sadani et al. That basically, in a very interestingly titled paper, is it great or terrible? Preserving sentiment in neural machine translation of Arabic reviews. Now let's now on the interplay between gender and languages, which is also a point of study in our paper. Gender in the context of understanding the cognition-language nexus. So it turns out that cognition and language kind of interact in extremely complicated ways. There is no monotonic narrative that basically tells that this is how language influences cognition or vice versa. And a very important subcontext of this is studied through the institution of gender. In this regard, psycholinguists have made tremendous contributions. Three papers that we personally enjoyed reading during the execution of the project are these. So firstly, you have the Revisiting Masculine and Feminine Grammatical Gender in Spanish, which also kind of talks about, beyond Spanish, like the nuances of how grammatical and natural gender emanates in different Romance languages. And then the second paper that we'd like to highlight is Language is a Girly Thing, Isn't It? A psycho-linguistic exploration of the L2 or the second language gender gap. And third is Niels Schiller's psycho-linguistic approaches to the investigation of grammatical gender. And what we saw was the emergence of very interesting ideological battlegrounds. To begin with, you have the or hypothesis, which is basically a principle suggesting that the structure of a language affects its speaker's worldview or cognition. And so you can kind of see that the directionality of the arrow comes from language to cognition. And thus, people's perceptions are relative to their spoken language. There are roughly two camps that have kind of invested faith in this kind of caricaturist understanding through the ages. They fall into linguistic determinism and linguistic relativity. Linguistic determinism, again, has two different flavors, strong determinism and weak determinism. And then there's kind of this third word of Joshua Fishman's Worfianism of the third kind. And then a kind of a softer version of this, or a milder version of this, is Slobin's thinking for speaking hypothesis. And all of this body of literature kind of has this ideological counterpart through Noam Chomsky's viewpoint, which is widely termed as the language acquisition device viewpoint, where his diktat is that language acquisition is a process that is largely independent of learning and cognitive development. United Nations basically kind of make 3 points that emphasize on use non-discriminatory language, make gender visible when it's relevant for communication, do not make gender visible when it is not relevant for communication. And with regards to gender, languages, and androcentrism, there was this extremely beautiful paper that we encountered by a European team of linguists and psycholinguists, where they basically say that all languages, at least the ones that they kind of pass through, many of whom are members of the Indo-European family, fall on a spectrum, with the extremes being languages with grammatical genders like German and genderless languages like Finnish and Turkish. And in between, you have 3 other categories based on, you have one hybrid category, which they call as group 1 or 2, which is a combination where the language has a combination of grammatical gender and natural gender languages like English, and genderless languages with a few traces of natural gender like Odia. And then in the context of understanding the bias that was exuded by Google Translate, there is the work of Pratish et al. In Brazil, where they basically downloaded a whole bunch of data with regards to United States Bureau of Labor's statistics. And then they basically kind of considered a bunch of languages, and they used a bunch of adjectives to try and understand the outcome or the biases or the gender biases with regards to the Google Translate API. Now, the next part we emphasize on trying to understand what is back translation, a technique that we use in our paper. And in this section, we kind of get some background knowledge on this. So translation is a technique that is increasingly being used where parallel data is scarce, in the sense that you are trying to translate between 2 languages, but you don't have large amount of data where you have like parallel sentences in language 1 and language 2. So if you kind of parse through the the disseminations made by Google, especially with regards to their M4 framework, you will see that translation is a very important and an integral part of their strategy. And especially in the context of what I term as low resource languages. the historicity of this technique has been in vogue since the important seminal work of Rico Sendrick et al. And Edunov's Understanding Back Translation at Scale. Data augmentation using back translation for context-aware neural machine translation has emerged in the context of Japanese to English translation and vice versa. It's also been used for consistency training, where this paper by Coakley et al. Kind of talks about this being like the NLP equivalent of the rand augment technique that we use in computer vision, where you have one image and then you kind of take random snapshots of that and then you augment it during training. So similarly, you kind of find an intermediate language and then you translate and you translate and you generate different versions or different rephrasings of the original language to beef up the amount of training data that you have. And it has been shown that this technique kind of improves a specific metric, which is called the BLUE. Now, back translation, especially in the context of low resource machine translation, is kind of gaining traction of late. In this slide, you'll see examples between Chinese and Vietnamese on the left-hand side, and another paper which did the same for English Turkish, Nepali English, and Sinhalese English translation tasks. And besides this, you have rapid democratization of tools. So now you have off-the-shelf libraries, and here we'd like to kind of place emphasis on two projects that we found were extremely popular towards implementing back translation in NLP pipelines. One is the Viet.ai's DAB package, and the other one is the option that is built into MarianMP. And this is another paper that basically used these translation techniques, used a large language model that is ULM fit, and they basically showed that back translation does improve the accuracy of downstream, low resource text classification task. Now, inspired by all of this and seeing the rapid emergence of back translation as a technique that is used for augmentation, we kind of try to paint a cautionary trail in this picture. In this paper. So in this section, we'll kind of try and explain the experiments that we conducted and the results that we obtained, and try to build a narrative towards the recommendations that we'd like to make. Experiment 1. This pertains kind of trying to understand the level of Androcentrism that exists in translation systems through the lens of back translation technique. So in this screen, you will see an example. In the top half, you'll see the the Turkish language, Turkish to English translation. So if you go to Google Translate and you type "Obir Doktor" in Turkish, the Google Translate API will kind of spit out two different options, because it understands that O is kind of gender neutral in the sense that the translation ought to be gender specific. And this has been in vogue since December 2018. Whereas you try to do the same in Hindi, "Wah ek doctor hai," but then you will get to see that it dramatically resorts to a male default. And then the worst aspect of this is that it says that it is verified, in the sense that the translation has been verified by Google Translate contributors. And you'll kind of see this stepmotherly treatment where there is inconsistency, where Google Translate kind of encountered this problem and the need for gender-specific translations. Yet, when it was implemented in the context of many other languages in the context of the Global South, they seem to have conveniently sidestepped all of these learnings. And now we have this back, the re-emergence of the male default appearing in, in these translation systems. So to try and understand how often does this happen, we came up with this following experiment. So firstly, we created a data set of 86 sentence prototypes based on 86 professions. So we collected this using, by and large, three data sets. One is the data set of professions that was available on GitHub, and then we combined it with the Merriam-Webster's dictionary of the most common jobs and professions. And then we kind of chose the professions that already were referred to in the paper. This is a brilliant paper, and we would like to very strongly recommend the readers to kind of take a read at this. It is Tracy Adams, Gender and Feminization in Healthcare Professions. And at the end of this, we basically ended up with 86 sentence sentence template, which is of the form she is or am a profession person. So like she's an advocate, she's an agriculturist, or she's a banker, she's a barber. And then what we do is we translate it. So you have the native, you have the English template, and then we do the forward translation into each of the 109 languages being offered through Google Translate. And then we back translate to kind of look at the fate of the pronoun she during this circular journey of forward translation and back translation. And we compute how often does she survive, and hence the term she survival rate. The result of this is basically an 86 times 219 translation back translation matrix. And here, for example, this first column indicates what happens when when web developer is basically translated into Bengali, and then it comes back into English. So it becomes a he. So you'll get to see these extremely interesting heat maps where for certain professions in certain languages, it does a decent job, except there are also large swaths where it defaults to the male or the masculine default, thereby indicating the androcentric bias. So let us kind of go ahead and measure these, the extent to which the androcentrism is exuded or exhibited in Google Translate API through measuring she survival rate. So this is basically the SSR analysis across all of the 109 languages. And you'll get to see that there's a large swath of languages where it performs really, really poorly. So what happens in these languages is that if you have a sentence, which is like she is a banker, and then you translate and you back translate, the back translate version will read like he is a banker. So here are the important nuances that emanated from this set of experiments. The mean SSR across all of the 109 languages was a mere 58.5%. So it's almost like close to coin toss. There's a 50%, close to 50% she erasure rate. And only 35 languages, about like 32.1%, had an SSR of 1. About 45% of the languages, the SSR was less than half. For Turkish, it appears as if it was kind of 0, but it's kind of accuracy of the API, because for every sentence that you input, it kind of almost always provides for 2 different, gender translated outputs. But we found that this happens only for about 86% of the sentences. And we also saw that with this very interesting phenomena, where mutually intelligible sister languages authored in different scripts yielded completely different SSRs, which basically talks about the idiosyncrasies of the way that the glyphs are encoded and then fed in the input pipelines into these NMT training paradigms. For example, Hindi, which is authored in the Devanagari script, and Urdu, which is offered in the modified Perso-Arabic script, had completely different SSRs of 0.128 and 0.419 respectively. And even more shocking was the comparison between Farsi, which is authored in the Persian alphabet, which is again derived from the the Arabic script, and Tajik, which is written in the Tajik alphabet, which is derived from Cyrillic, of 0.058 to 0.919. And we also saw similar discrepancies between Turkish and Azerbaijani, which now, SSR analysis across different professions. Here, what we do is we aggregate, we kind of combine across all languages, and we kind of benchmark it across professions. And we get to see a very interesting, distribution of SSRs, where the bottom 3 worst performing SSRs, like professions where the odds of she coming back as she is the least, were in fact things like human resource specialist, aircraft pilot, clergy advisor, and medical laboratory scientist. And the 3 professions where the she survival rate was 100% are professions which are oftentimes deemed to have a pro-feminine bias, like the licensed practice nurse, midwife, and registered nurse. Now we kind of do this deep dive into SSR analysis in geographical context, specific onus being on Africa and India. And here we also used some of the nuances that we were able to glean from the World Atlas of Languages. And we'll see that, we all know that Africa is extraordinarily linguistically diverse. So depending on whether you're seeing the languages with regards to the Western African context, or in the Horn of Africa, or in the Sub-Saharan context, or in the MENA region, it takes completely different, the way that the gender is addressed in these languages is very, very different. And now, does it really matter which language family a language belongs to, and the way that gender is addressed in that language? And we found the answer to that question is yes. We see this extraordinarily sharp schism between the bad results that we obtained for the Niger-Congo family versus the Afro-Asiatic family that has members such as Maltese, Hausa, Somali, and Amharic. With regards to India, the Indian constitution has two articles, 344(1) and 351, that basically, as part of the 8th schedule, that includes the following 22 languages. And again, here we saw, like in the case of Africa, we had seen the schism between Afro-Asiatic and the Niger-Congo family. Similarly, we found this interesting schisms where we had like 7 languages that performed really poorly and 6 languages where we had really good SSRs. So here are some interesting nuances. So Oriya performing poorly should not come as a shock, given the fact that there is a fair amount of linguistic literature that talks about by and large genderless language, but it does have a few traces of natural gender. And then you had the Southern Indian languages, or the Dravidian languages such as Tamil, Kannada, and Malayalam, and surprisingly enough, even Sindhi, where the SSR was close to 1. And we also saw, like, as pointed out previously, that there was a vast difference between Hindi and Urdu, even though they are mutually intelligible sister languages. And in this specific context, we would like to kind of highlight this little extremely important anecdote. With regards to the example of she is a doctor, we'd like to kind of present the extremely important storyline of Dr. Rashid Jahan. She was a member of the Communist Party of India, and she was a firebrand feminist, a scholar of the subaltern. And in this article that was titled Dr. Rashid Jahan, a spark that lit the fire, there's a mentioning of a very interesting book that she authored, which was literally titled Woke, and the different connotations that the word takes in the context that it's used in the rural subaltern colloquial space. With regards to the 13 Indian languages, we ended up with a 86 by 13 cross-tab matrix consisting of 1,118 inputs. And we saw that the she survival rate was 613 out of 1,118. The reason why we kind of provide this plot is to basically motivate to start thinking of translation. And this is purely because of the fact that one of the main authors of the study has a background in information theory, and it might be very instructive and useful for us to study these translation systems from the viewpoint of asymmetric noisy erasure channels. So in the case of she is kind of retained as she with a probability of 0.548, and she is erased in the form of like they, that, and it with the probability of 0.0107, and she becomes he with a probability of 0.441. Experiment 2, enantiosemy. So this part of the work was inspired by a tweet by a colleague of ours with whom we have collaborated in the past. Abel is a PhD student at Stanford University, and his tweet basically talked about bias in Google Translate, where he kind of emphasized on using this contronomous word that is enjoined. And then he was kind of demonstrating how there could be Islamophobic bias, and generally Google actually has a tendency to kind of always bank towards the negative connotation, which is exhorting the violence, ordering the violence, whereas enjoin emerges in the legalese context, specifically where the court basically condemns the violence. So we try to kind of put get a statistical understanding of how often this has happened across all of the languages. So we do 2 experiments. So the first experiment is the latitudinal experiments, where we kind of take one sentence, the court enjoined the violence, across all of the 109 languages to see what is the translation that Google provides. And again, we kind of use the root of back translation to try and understand what is the fate of the sentence upon back translation. On the left-hand side, you'll get to see some of the examples across the first 54 languages, and you will kind of get to see a scary level of prevalence of whether of the code actually ordering the violence. You can see the code ordered the violence, the code prescribed the violence, code orders the violence. So this is kind of very scary revelation. And when we repeated this across the remaining 55 languages, we saw the same thing. And it was very interesting that in Thai, it basically switched the word from code to police, and it said police charge violent incidents. And then in Urdu, in fact, it says code orders torture. So we have kind of curated these data sets for further annotation. But by and large, we found that in most of the cases, the Google Translation API actually ends up, if you're looking at the back translated versions, almost 100 of the 109 cases, it actually kind of is biased towards prescription of violence rather than going away from or basically translating that would, basically enjoin the violence or basically condemn the violence. The second experiment that we did in this context is what we call as a longitudinal study, where it's one language, and then we created multiple contronomous sentences that were handcrafted by using different contronomous words. And then we saw what happens when we kind of translate and back translate with regards to specific languages. So on the left-hand side, we basically see the sorted results that we obtained with regards to Igbo. On the right-hand side, we saw this with regards to Kannada. Now, the question is, who is to say whether these translations are the wrong translations? To which we say that that is exactly our point, in the sense that the seemingly mistranslated versions so in the absence of a context. So we kind of motivate that by translation, there ought to be a case for abstention modeling, where if it is too context dependent and you cannot really come up with a faithful translation that is risk-free, then we kind of would like to motivate the fact that the translation should kind of come up with an abstention class choice, where there is at least a caveat that is thrown in for good measure, saying that this translation can be highly susceptible to misinterpretation. And like we stated, we are now curating and releasing this as a data set for further annotations to the NLP community. And based on the experiments and results that we obtained, we have the following recommendations. So first and foremost, we hope that Google will fix this, the verified sign, because in this case, the language, the sentences were a Dr. Heck in Hindi, and that is translated with an androcentric bias of he is a doctor. It could be he or she. It's not very clear. But then the issue is that this is a case of overconfident misprediction, where this sign, which basically says verified, kind of goads a user to believe that it must be correct. And it's a source of misplaced confidence. So we hope that this is fixed. And the second recommendation we'd like to make is to provide confidence scores if possible, or to kind of allocate research efforts towards coming up with confidence scores associated with these translations. And in the video that you get to see in the left-hand side of the screen, you will see that, contrary to what the deep learning community believes, Quest for AI has always had the need for understanding the level of confidence in the decision being made by a system, by an artificially intelligent system. So, we hope, and actually Google provides for, different granularities of confidence as part of its Google Vision suites. But then there is no such affordability being, made through the Google Translate APIs. And we kind of argue that when pseudoscience like emotion classification is getting so much attention to detail, why is it that a more crucial application such as language translation is being left in the wake? The third recommendation has to do with abstention class or rejection learning. And in our previous work, we looked at the landscape of out-of-distribution failures And then while trying to understand the now, or how do we fix this part of the story, we've kind of focused on the previous research that was done in the context of human-in-the-loop learning. So there are three paradigms that emerge: abstention class modeling, where you explicitly tell the neural network to basically abstain from making a decision because it's too risky, and the downstream effects can have like a profoundly negative hue. And then there is the second paradigm of rejection learning, and the third associated with this being similar to abstention class modeling, which is learning to defer. We hope that some of these techniques are used with regards to language translation, where the neural network has enough humility to basically say that it is not being able to confidently make, or there's too much subtlety and contextuality involved to make a confident translation. And associated with this, again, this was kind of also motivated by contronomy. Like I think if we can use a simple lookup table-esque approach to kind of identify the presence of contronyms in a sentence, and we can kind of use this knowledge and kind of build this as statistical pairs into the model, where the neural network knows that the presence of a contronymous word renders the whole translation to be resting on shaky ground. So we can kind of use these ideas to kind of motivate this abstention class or learning to defer paradigms. Fourth, extend gender-specific language translations to all the languages applicable. So like I said, we've actually kind of seen a regression of sorts, where 2018, there was already an acknowledgement of this problem, and there was a need for providing gender-specific translations. Whereas this has been conveniently forgotten when Google Translate was kind of ushered in for other languages in other corners of the global south. Fifth, model cards for M4 and GNMT and other models that are being deployed for neural machine translation. Right now, like Google AI ethics team basically some time back proposed the model cards, where you kind of be able to click and understand what are the shortcomings of this model, what is the data set that was used, and what are the statistics associated with the model that you're interacting with. And this would eventually kind of give the end user an idea as to what could be the possible frailties, and this could be extremely useful for the developers as well. But surprisingly, we found that with regards to M4 model or the GNMT models, there were no model cards being made available. Recommendation 6, increasing the corpus of text and basically hiring local language experts. For example, when we kind of pass through some of the blog posts that were made on Google's AI blog, we saw like usage of terms such as low resource languages with regards to languages such as Yoruba or Malayalam. And I'd like to argue that the very assumption that these are low resource languages is something that is worthy of being questioned, especially with regards to Malayalam. You have so Kerala, which is the state in which Malayalam is spoken the most, is one of the most literate states in the country, and you have media houses such as the Malayalam Manorama that provide basically bilingual services. So they have a vast treasure trove of articles that are basically found in both the native language Malayalam and in the English version. And this screenshot from the Audit Bureau of Circulations indicates the vast wealth of newspapers in active circulations in India. Like, for example, Malayalam Manorama alone has a total circulation size of 2.3 million active consumers of the paper. And you will see similarly large numbers with regard to many of the local languages. And many of these newspapers do offer their news services in both English and in that language where it's being offered. So we hope that there will be, ushering in of more strategic partnerships with a fair revenue sharing model, so that we can improve the state of the art of the neural machine translation, and also try and understand that this cavalier usage of terms like low resource language actually has, you're kind of importing the negative views that are harbored within the global north circles. The seventh recommendation we'd like to make is to invest in research to understand the flow of gender across translation devices. like psycho-linguistic research has kind of demonstrated how extraordinarily difficult it is to kind of even come up with a monolithic narrative to try and understand the interplay between the tripartite interaction between gender, cognition, and language. And they have a whole wealth of nuances that is sensationally amiss when you look at the NLP neural machine translation papers. And it'll be useful for Google to kind of build a kind of a cross-disciplinary team that has a fair amount of linguists and psycholinguists contributing towards improving the state-of-the-art in neural machine translation systems. 8th recommendation entails regular auditing using local language experts. And in this, we'd like to celebrate the work of a linguist named Aremu Adeola Jr. And he basically kind of, in his article titled Lost in Translation, Why Google Translate Often Gets Yoruba and Other Languages Wrong, he comes up with 4 extremely interesting reasons. The first reason he says is due to the inadequate or inaccurate accent marks used to indicate tones. He also remarks that most people are not so good with orthographies, and that might result in poor, source data, which when amalgamated with the idiosyncrasies of the back translation paradigm might actually make things much worse. And third is where he talks about cultural nuances, and he gives examples of Yoruba words such as ayaba, and he notes that most machines translate both words as queen. However, a translational and cultural vantage point, it is essential to note that the meanings of the ayaba and obabindrin are different. Obabindrin means queen in English, and ayaba is the wife of the king. So there are these cultural nuances that these neural machine translation systems fail to kind of grasp. Then you have the problem of the influence of tech has basically given rise to a vast plethora of words for air conditioner, phone, and grinder, and telephone, and vehicle. And it might be the case that the language is actually changing so rapidly that you have to kind of pay heed to the CI/CD model updating loop of these NMTs. So all of these nuances is already available, and this knowledge is already available in the with regards to the local language experts. We wish that an organization such as Google will harness the wealth of expertise that is available before ensuring that their model is worthy of real-world deployment. 9th, incorporate bias-sensitive metrics like the way that we kind of dealt with SSR into technology evaluation before considering real-world deployment. If you kind of pass through Google's research principles, they basically, we encountered the statement which says machine translation started as a fundamental research exploration and became a product when the translation quality received a sufficiently high quality bar, which implies that internally there must have been a metric or a set of metrics, breaching of which, of the threshold of which the thing was deemed to be worthy of real-world implementation. And what we would like to point out is that if you kind of go through certain public disseminations that had very high PR value, such as this one where they claim that they were on the cusp of breaching the human level quality for English to Chinese to English, or these GIFs that they have kind of shared on their sites, there seems to be this almost single-minded fetish towards blue, which actually has been, and there's a lot of critical literature that exists within NLP community that talks about the shortcomings of blue as a metric. And we hope that the real world deployment is kind of carried out in a much more careful fashion by not only considering accuracy metrics such as blue, but also considering gender bias metrics like the ones that were proposed, such as the she survival rate and so on and so forth. With this, we would like to conclude the talk. We hope that you have learned something new, and we hope you will visit our poster session and ask any questions that you might have. Thank you.